Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Physics Chapter 2 Work, Energy, Power. We will be discussing about the different forms of energy. In the previous class, we have discussed what work, energy and power is. We have studied about the units and measurements of it. Hope you all have watched that video. If you haven't watched, go watch it first, then come back to this video. We'll study together. First, we are going to discuss about mechanical energy. Mechanical means something it is related to moving, I think. Okay. So, this is the energy possessed by a body due to its state of rest or motion. Here you can see a scooter is moving. Due to this motion, there is some energy and this energy is a mechanical energy. Here you can find a person who is moving along a mountain in a cycle. So, initially at this point he has energy. When he reaches this point, he has some energy. To move down also he has some energy. Okay, for a body to move or to stay at rest, it will be possessing some energy and this energy is called mechanical energy. Mechanical energy is actually the sum of two different types of energy. They are potential energy and kinetic energy. Okay, so potential energy and kinetic energy. When you take the sum of these, you will be getting mechanical energy. Mechanical energy is equal to, mechanical energy of a body at any particular point will be equal to potential energy plus kinetic energy. So, you want to know what is potential and kinetic energy, right? Now, we will be discussing about potential energy and kinetic energy in detail. To study about potential energy, we are going to do a small experiment. Here I have a rubber band and a piece of paper in my hand. What I am going to do is, I am placing the paper here and pulling the rubber band back and I am releasing. What happens? The paper has flied, okay? The paper has moved. Now, since the paper has moved, the paper should have gained some energy to move, right? When the paper was at rest, it was not able to move. What I have done? I have taken this rubber band, placed the paper here and I have pulled it backward. Okay. When I pulled it backward, I am changing the shape of this rubber band. By changing the shape of this rubber band, what happens is some energy is getting stored in this. Okay. This rubber band is possessing some energy. This energy helps the paper move forward later. Okay. Now consider all these examples. Here you have a boy who is having a bowl in his hand. Okay, he has got a bowl in his hand. What is he doing? He is putting the bowl down. Now, when the bowl is held here, it is possessing some energy actually. Okay, then this energy will help the bowl move downwards. So, at every point it is possessing energy. Okay, to hold the bowl here, he is actually applying a force and holding it. So, because of this force, because of his work done, the body, that is the bowl, is possessing some energy. The body is at rest. Okay. So, this is the position in which the bowl is held. At this position, it is possessing some energy. Now, take this case. So, here you have a cyclist, he is cycling and reaches this point. Okay. At this point, he is at rest. But still he has got some energy to move down. Even if it doesn't pedal, he will be able to move down because of the energy that is stored with him. Next, take this case. Okay, here what is happening? A hammer is used to move the nails inward. Okay, here the nail is going inside. How is it going? A force is being applied using the hammer. Okay, here if this is your nail and just I am hitting with the hammer, a slight hit, will it move? No, right? What will happen? It won't move. When the hammer is taken to a height, that is, when hammer is taken to a height, it is gaining some energy and this energy will help when the force is being applied, the nail to go inside. Take this case, here we have a bow and arrow. When this arrow is pulled with this rubber band, it is pulled backward, it is gaining energy. That is, there is a change in shape. Okay. The shape is changing. The shape of this rubber band is changing. And this change in shape helps the body, that is the arrow, to move. Okay, in all these cases, the body is possessing some energy. And this energy is what potential energy is. So we can define potential energy as energy possessed by a body at rest due to its position. So consider these cases. Here, the ball is raised to a height. Its position gives it energy to move later. Even in this case, at what height the hammer is taken, then it helps to move the nail inside. Okay. Possessed by a body at rest due to its position or size and shape. In this case, it is the shape. Even in the case of rubber band and paper, it was a shape which helped the paper or the arrow to move forward. Okay. Change in shape is called potential energy. So understood, for a body at rest, even a body at rest possesses some energy, and this energy is potential energy. The potential energy depends on the position, size and shape of the body. Clear? Next, we will be discussing two types of potential energy. First one is gravitational potential energy and the second is elastic potential energy. What is gravitational potential energy? We know that every body on this universe is attracted towards the center of Earth. Here, you can find an apple that is falling to Earth. Why? Because Earth attracts. There is a force of gravity. Force of gravity is always acting downward, which pulls every object towards the center of Earth. Now, gravitational potential energy is the energy required to move an object, to attract an object to the center of Earth. Okay, understood what gravitational potential energy is. Now, when the apple was on the tree, it possessed some energy and this energy is gravitational potential energy. The apple is able to maintain this position. At this position, it possesses some energy. Okay, because of this energy only, it is able to fall down later. This energy is getting released later. Okay, this energy, that is when a body is held at a particular height. If I am lifting a box from the floor, it is lifted to a height. Okay, so when it is moved through this height, it is possessing some energy and this energy is gravitational potential energy. Potential energy that is possessed by a body due to the force of attraction of Earth on it is called gravitational potential energy. So at infinite distance from the center of Earth, what happens? Gravitational potential energy will become equal to 0. So the distance when it becomes maximum, when it becomes infinity, what happens? Gravitational potential energy will become 0. Now, here, the distance of a body from the surface of Earth. When the distance of a body from the surface of Earth increases, when distance increases, force of attraction of Earth decreases. In that case, gravitational potential energy will increase. Okay. Then, similarly, when the distance decreases, what happens? Force of attraction of Earth, it will increase and then gravitational potential energy will decrease. Gravitational potential energy is against the force of gravity and it is always taken as negative. Okay, gravitational potential energy will be negative. If I am lifting an object, here by lifting the object, what I am doing? Force is acting downwards and I am lifting it. I am applying a force in the opposite direction. Therefore, gravitational potential energy will be negative because they are in opposite direction. Okay, then at infinite separation, what happens? Gravitational potential energy will become equal to 0. Okay, to bring a body at infinity to a particular point, the energy required is what gravitational potential energy is. Understood? We discussed about gravitational potential energy and gravitational potential energy depends on the position we said. So what is potential energy? Potential energy is the energy due to position, shape or size of an object. Here, gravitational potential energy is related to position. Now, when it comes to shape, take the case of this rubber band. So, when this rubber band is expanded, what is it happening? There is a deformation, there is a change in shape, okay. So, when I release it, it will be coming back to its original shape. So, when I have stretched this rubber band, what is happening? I am applying a strain, I am applying a force. Because of this force, energy is getting created. This is what elastic potential energy is. Now, this elastic potential energy will get stored in this body and that helps the body to regain its shape. So, once I release, what happened? It will regain its shape. Right? It will regain its shape. What is happening? The energy that gets stored once stretched, when it was stretched, the energy gets stored. This stored energy helps it to move through this distance and come back to its original shape. Take these examples. Here you have a bowl and this bowl is used to compress a spring. So when pressing, compressing a spring means you are pressing the spring it becomes like this. Okay. Now what happens? It will have a tendency to go back to its original shape, right? To come back to its original shape. What happens is when the ball is released, it will just jump from here. What is the reason? Now when the ball is being pulled down, that is when the spring is getting compressed, what happens? An energy gets stored, an energy gets created. This is elastic potential energy. Now this elastic potential energy of the spring helps the ball to gain some energy, and this ball will start raising up. Okay, this is what happening in this case. So a compressed spring will have a tendency to come back to its original shape. So the stored elastic potential energy helps it to come back to its original shape. When it comes back to this original shape, what happens? The ball will gain some energy from this, and this energy gained will help the ball to fly. Okay. Okay, take the case of this arrow and a bow. With the bow, you have a string here. When the string is stretched with this arrow, what happens? In the string, elastic potential energy is getting created, and this energy gets stored here. Once you are releasing, what happened? Once you release the string, what happens? The string will have a tendency to come back to its original shape. So this is how it goes. It will have a tendency to come back to its original shape. Then what happens? Once it comes back to its original shape, the energy gets transferred to this arrow, and the arrow will move forward. Okay, this is what happened. So, understood what is elastic potential energy? Potential energy that is possessed by a body in the deformed state due to change in its size and shape is called elastic potential energy. Gravitational potential energy is related to position. Elastic potential energy is related to the size and shape. So, a deformed state, in the deformed state, it possesses some energy, that is changed state. Clear? Next is gravitational potential energy at a height. When you are lifting a body to a height, what is happening? The body is gaining the gravitational potential energy. Here you have a mass, a body of mass m. It was initially on the ground. Now it is raised to a height of h. Okay, it is raised to a height h. It has gained some energy, and this energy is stored in the body as gravitational potential energy. Okay, now how to find gravitational potential? Gravitational potential energy of a body at a height above the ground is measured by the amount of work done in lifting it up from the ground to that height against the force of gravity. We know that anyways the ball which is lifted up will have the force of gravity acting on it. Force of gravity will be acting down, or the weight of the body will be acting down. Against this force of gravity, we have to do a work. At least we have to apply a force that is greater than the weight of the body. If you are applying a force which is less than weight of the body, you won't be able to lift the object, right? So you should apply a force which is greater than the weight of the body, or equal, at least equal to the weight of the body. Only then you will be able to lift the object. So once you lift, what is happening? You are doing a work, right? So work is equal to force into displacement. That is, to lift this object, you have applied a force and there is displacement. The body has displaced through a height of h, which means there is force and displacement. Work is force into displacement. Here, what is the force? Force is nothing but the weight of the body. You are applying a force which is at least equal to the weight of body, mg. What about displacement? Displacement is the distance it has moved from ground to a height h. Okay, displacement is h, which means the work done is equal to mgh. M is the mass of the body, g is acceleration due to gravity, and h is the distance through which it has moved. Now, this work done gets converted into the energy in this body. Okay, so this body will possess an energy. It gets stored in the body as energy, and this work done is the energy. So, gravitational potential energy is represented using the letter U. U will be equal to mgh. We understand? Here, gravitational potential energy depends on mass, acceleration due to gravity, and height. Mass is a constant for a body. Acceleration due to gravity will have only a single value, that is 9.8 meter per second square. What about height? When height increases, gravitational potential energy also increases. In this case, we are considering the object is raised from the ground. Okay, at the ground height will be equal to 0. Height is 0. When height is 0, gravitational potential energy U0 will also be equal to 0. Gravitational potential energy on the ground we have taken as 0. Clear? Now consider these two cases. Here a girl is throwing a ball upwards. Okay, the ball is moving upwards. Here we have a boy who is putting a ball downwards. Okay, take the first case. Here we know that potential energy, gravitational potential energy U is equal to mgh. Okay, now take the case of girl. Here when the ball is thrown up, the ball is moving upwards, which means height is increasing or decreasing? Height is the distance from the ground. Is it increasing or decreasing? In this case it is increasing, right? Maximum height will be at this point. Okay, when the height increases, what happens to gravitational potential energy? Gravitational potential energy will also increase, because here it is clear that height and gravitational potential energy are directly proportional. So when height increases, gravitational potential energy increases in this case. Okay, clear? So at maximum height there will be maximum gravitational potential energy. Now take the second case. What is it happening here? Initially the ball was at this position, shifted to this position, then this position. Okay, that is when a ball falls down, what is happening? Height is decreasing. Height from the ground is decreasing. So here U is equal to mgh. When height is decreasing, what happens to gravitational potential energy? Gravitational potential energy also decreases, because it depends on height, directly proportional to height. When height increases, gravitational potential energy increases. Height decreases, gravitational potential energy decreases. Finally, when the ball strikes the ground, what is the gravitational potential energy? At the ground, height will be equal to 0. Okay, when height becomes equal to 0, U is equal to mg into 0. That is, U is equal to 0 on the ground. On the ground, gravitational potential energy will be equal to 0. Now consider a case. Here, an object, that is a body which was at a height h1 initially, is lifted to a new height h2. Okay, initially the body was here, it is lifted through this much distance to a height h2. What happens to potential energy? Does it increase or decrease? It will surely increase, right? Why? Because height is increasing. This is called gain in potential energy. Gain in potential energy. Let's find the gain in potential energy. Gain potential energy depends on the initial potential energy and final potential energy. So gain in potential energy, the change in potential energy is final potential energy minus initial potential energy. Okay, here what is the final potential energy? Final potential energy is the energy possessed by the body at a height h2. Mass does not change, acceleration due to gravity does not change, height becomes h2. Therefore, mgh2 is the final potential energy. What about initial potential energy? Depends on the initial height, which is h1 minus mgh1. Okay, taking common outside, mg is common, then h2 minus h1. So the gain in potential energy will be equal to mg into h2 minus h1. Okay, understood? Gain in potential energy is mass into acceleration due to gravity into the second height, the new height minus the first height h1. So this is the gain in potential energy. Clear? Let us take an example. A body of mass 5 kg is taken from a height 5 meter to 10 meter. Find the increase in its potential energy. Take acceleration due to gravity. G is equal to 10 meter per second square. Okay. Here what is given? Mass of the body is given. Mass m is equal to 5 kilogram. Initial height h1 is given, which is 5 meter. Final height h2 is given 10 meter. Acceleration due to gravity is given 10 meter per second square. what we need to find is increase in the potential energy, change in potential energy or gain in potential energy. Increase in potential energy is equal to final potential energy minus initial potential energy. Okay, we don't need to find it separately. We have a formula ready-made, that is mg into h2 minus h1, where m is the mass, g is acceleration due to gravity, h2 is the final height and h1 is the initial height. Substitute the values. Mass is 5, g is 10, h2 is 10 meter, h1 is 5 meter. Okay, so that is 5 into 10 into 10 minus 5 is 5. 5 into 5, 25, 25 into 10, 250. What is the unit? Unit of energy will be joules. Unit of work and energy are same, potential energy. Unit of gravitational potential energy will also be same. Therefore, the increase in potential energy is 250 joules. Okay. Next, we are going to discuss the second type of mechanical energy, which is kinetic energy. Have you ever imagined why a ball that strikes a window pane suddenly gets broken? Okay, a boy who is hitting a cricket ball and this ball goes and strikes a window pane, and what happens? The window pane will surely break. The window will break. Okay, or when a bullet is fired, a bullet is a very small object, right? When a bullet is fired, when this bullet hits a person, he will die. Does the bullet have any energy? The bullet possesses some energy, and this energy is what kinetic energy is. So, the energy possessed by a body due to its state of motion is called kinetic energy. In all these cases, first we have taken the case of a ball. When the ball is moving, what is happening? Its velocity is increasing. Okay, there is motion. Its velocity is increasing, and suddenly when it strikes a window, what happens? The window will break because of that energy that is gained by the ball. Even this is the same case with bullet. Bullet, the small object, has gained some energy, and this energy kills the person. Now take this case. Here, when this carom coins is struck with a striker, what happens? Coins will move. Now, does this coins have an energy? No, right? When this striker starts moving, that is, we are applying a force on the striker and the striker starts moving. While moving, it gains some energy. Due to the motion, it gains some energy. Okay. This moving object, when strikes another object, there is a transfer of energy, and this transfer of energy helps objects to move. When an apple is falling, while falling, what is there? There is motion. Apple is in motion. So, it is said to possess kinetic energy. A car that is moving, there is kinetic energy. There is motion, there is kinetic energy. So, we studied potential energy is for a body that is at rest because of its position, shape and size. When it comes to kinetic energy, the energy that is possessed, that happens due to the state of motion, is called kinetic energy. The basic difference between potential energy and kinetic energy is potential energy is for a body that is at rest. Kinetic energy is due to the state of motion. Okay, and kinetic energy is represented with the letter. Next, we are going to derive an expression for kinetic energy. We know that kinetic energy possessed by a moving body is equal to the amount of work which the moving body is capable of doing before coming to rest. Consider a case, a car is moving, you apply brakes, what happens? The body starts retarding, there is retardation, okay, and the body will finally come to rest. Here we have two examples, that is, this is a stationary ball. A stationary ball has no kinetic energy. When it starts moving, what happens? There will be kinetic energy, okay. Now here you have a bullet inside the gun. There is no kinetic energy. When the bullet is fired, that is, bullet starts moving, there is kinetic energy. Okay. Similar is the case, a moving body will be having kinetic energy. When it comes to rest, there is no kinetic energy. You have a body of mass m, okay, which is moving with a velocity v, which means the initial velocity is equal to v meter per second. Suddenly what happens is a force is applied, a brake is applied in case of a car, and the body comes to rest, that is, slowly the speed starts decreasing or velocity decreases and the body will finally come to rest. Okay. At rest, what is the velocity? Final velocity will be 0 meter per second. It has moved through a distance. Let us say S is the distance it has moved, which means displacement is S. Now, we have work is equal to force into displacement. What is force? According to Newton's second law of motion, we have an equation for force which is F is equal to ma. Okay, F is equal to ma is the force. Now, displacement. We need a relation between displacement and velocity. We have studied 3 equations of motion. What are they? First one, V is equal to U plus AT. Second, S is equal to UT plus half AT square. Third, V square is equal to U square plus 2AS, which is a relation showing velocity and position relation. We have 3. Okay, here it is time and velocity, here it is position and velocity, and here you have velocity position or velocity displacement relation. So, using this, you are going to make an expression for S. We have final velocity V is equal to 0. 0 is equal to initial velocity U is taken as V square plus 2 into acceleration is negative in this case. Okay, it is retardation. Therefore, we have to take minus A into displacement S. Okay, now taking this to the opposite side, we get 2AS is equal to V square. Okay, minus 2AS when taken to the opposite side becomes plus 2AS. Then what is S? S will be V square divided by 2A. V square by 2A. Displacement S is V square by 2A. Here, divided by 2A is equal to S is your second equation. Now, substituting for work, we get work is equal to force MA into displacement, which is V square divided by 2A. Okay, A and A can be cancelled. Then what we have? Work is equal to half mv square. So, here we have the kinetic energy possessed by a moving body is equal to the amount of work which the moving body is capable of doing before coming to rest. This work is the kinetic energy. Because of motion, we have this work. This work is done to bring the body at motion to rest. Okay, this work done is the kinetic energy. Therefore, kinetic energy is equal to half mv square. This is the relation for kinetic energy. Okay, half mv square, which means kinetic energy of a body depends directly on the mass. When mass increases, kinetic energy also increases. What about velocity? Kinetic energy is directly proportional to the square of velocity. Okay, if the velocity becomes 2 times, let's say the new velocity v dash is 2v. What happens to kinetic energy? We have kinetic energy is equal to half mv square. Now, new velocity is v dash. What is v dash square? It will be 2v whole square, which is half m into 4v square. 2v whole square is equal to 4v square. Taking this 4 outside, 4 into half mv square. Okay, that is, this is the original kinetic energy, which means when the velocity becomes 2 times, what happens? Kinetic energy will becomes 4 times. 4 times of the original kinetic energy. Okay, this is how kinetic energy depends on mass and velocity. Clear? Take an example. Calculate the kinetic energy of a body of mass 2 kg moving with a speed of 10 meter per second. Mass is given, speed is also given. Mass m is equal to 2 kilogram. Velocity or speed v is equal to 10 meter per second. We have kinetic energy is equal to half mv square. Just need to substitute to get the final answer. Half into mass is 2, velocity is 10. 10 square. 2 and 2 gets cancelled. What is 10 square? 100. Okay, 100. Now, what is the unit of kinetic energy? We said the unit of work and energy are the same. Kinetic energy is a type of energy. Therefore, 100 joules is the kinetic energy. Okay. Third example. How is the kinetic energy of a moving cart affected if its mass is doubled? First case, and the second is its velocity is reduced to 1/3 of the initial velocity. Okay. Let us take the first case. So here you are considering a body of mass which is moving with the velocity v. When you have a body of mass m and velocity v, what is the kinetic energy? Kinetic energy will be half mv square. Okay, the original kinetic energy is half mv square. Now what happens in the first case? Its mass is doubled. Okay, therefore the new mass, let us take it as m dash is equal to, doubled means it becomes 2m. Initial mass is m. When it is doubled, it becomes 2m. Okay. Here the kinetic energy Ke dash is equal to half m dash v square. Velocity is the same. Okay. Now substitute what is m dash? M dash is 2m. 2m v square. Now taking this 2 outside, 2 into half mv square. So the new kinetic energy Ke dash is equal to, either you can represent it as Ke or K. Okay, Ke dash is equal to 2 into half mv square, which is 2 into half mv square is the original kinetic energy K. Okay, so when mass is doubled, what happens to kinetic energy? Kinetic energy also doubled. Okay, now take the second case. In the second case, what happens? Its velocity is reduced to 1/3 of its initial velocity. Okay, let us say the initial velocity is v. The new velocity. What is the new velocity? Its velocity is reduced to 1/3, which means 1/3 of the original velocity, that is v by 3. Now kinetic energy K dash is equal to half m v dash square, that is half m v by 3 whole square. Okay, v dash is v by 3. Half m v square divided by 3 square is 9. Okay, I am taking out this 1/9, then the remaining half m v square. Kinetic energy K dash is 1/9 times half mv square. Half mv square is the original kinetic energy. Okay, so K dash will be 1/9 times the original kinetic energy. Okay, 1/9 times the original kinetic energy. That is kinetic energy reduced to 1/9 times. Fine. Okay, next let's see what's the relationship between kinetic energy and momentum. Momentum is a word you all are familiar with. Momentum is the product of mass and velocity. Consider a case, you have a car and a lorry. Okay. Here we said that mass and velocity are the factors on which momentum depends on. Momentum is the product. Momentum is represented as P, which is the product of mass and velocity. Here this car and lorry are moving with the same velocity v. Which will have greater momentum? Yes, lorry will be having greater momentum. Why? Because in this case mass is higher. Okay. Take another case, two bodies of same mass m. The first body is moving with the velocity v1, second with the velocity v2. Second velocity is greater than the first velocity, v2 greater than v1. Then which body will be having greater momentum? Momentum will be higher in the case of the second body. Why? Because here the second case the velocity is higher. Momentum depends on both mass and velocity. When mass increases, momentum increases. When velocity increases, momentum increases. So here we have P. Momentum P is equal to mass into velocity. We have derived an equation for kinetic energy. Kinetic energy is half m v square. Okay, this is your first equation. Now we are going to compare the equation for momentum. P is equal to mv. The second equation and the first equation. From this equation we have velocity is equal to P by m. Okay, we are taking this m to the opposite side. then velocity will be P by m. You are going to substitute this in the first equation. Then kinetic energy will be half m into P by m whole square. That is half m P square by m square. Here we have a mass m in the numerator and 2, that is mass square, in the denominator. 1 m can be removed. Okay. Then we have P square by 2m. Therefore, kinetic energy is equal to P square by 2m. Okay. Or you can rewrite this as, we'll be having P square is equal to 2m into kinetic energy. Okay. I'm taking this 2m to the opposite side. 2m into K is P square. What is P? P will be equal to root of 2m into kinetic energy. So, these two relations, that is kinetic energy is P square by 2m. On rearranging, you will be getting momentum is equal to root of 2m into kinetic energy. This is the relation showing kinetic energy and momentum. How momentum and kinetic energy are related. Let us take a case. If a light body A of mass small m and a heavy body B of mass capital M both have same momentum P, then the kinetic energy of the light body A will be more than that of the kinetic energy of the heavy body capital B. Okay. What is the kinetic energy of first body? Of body A? Half m P square. Here we need a relation between momentum and kinetic energy. The relation is P square divided by 2m. So, kinetic energy of the first body Ka is P square divided by 2m. What about the second body B? Kb will be equal to P square divided by 2 capital M. Now, let's make a comparison. Here we will understand that mass and kinetic energy are inversely proportional when momentum is taken into consideration. Momentum is same in both the cases. Okay. What is Ka by Kb? Ka by Kb will be equal to P square divided by 2m, P square divided by 2 capital M. Now take the reciprocal and multiply. P square by 2m into 2 capital M by P square. P square gets cancelled, 2 gets cancelled. Then we have capital M by small m. Capital M is mass of the second body or B. Small m is the mass of first body or A. Okay. Here Ka by Kb is capital M by small m, which means here we have m less than capital M. Okay. Mass of the first body is less than mass of the second body, and it is inversely proportional to kinetic energy. Therefore, kinetic energy will be greater for the first body, Ka greater than Kb. You can see here you have Ka, and in the denominator you have the mass of that body. Okay. Ka is the kinetic energy, that is you can see a cross relation or inverse relation. Therefore, the smaller body or the body of lighter weight will be having greater kinetic energy only when put the momentum P is a constant, not in other case. Okay. Here given that momentum is a constant, you have to consider that. When momentum is a constant, then the lighter body will be having greater kinetic energy. Clear? Now the second case, if a light body A of mass m and a heavy body B of mass capital M both have same kinetic energy, then the heavy body B will have more momentum than the light body A. Take momentum of first body. Pa will be equal to root of 2mk. Okay, K is the kinetic energy of both the bodies. Okay, mass of the first body is small m. Momentum of the second body, Pb, is equal to root of 2 capital M K. Kinetic energy is a constant. Now for comparison, take Pa by Pb. Momentum of first body divided by momentum of second body will be equal to root of 2mk by root of 2 capital M K. Okay. Root is common. Then 2 can be cancelled. K can be cancelled. Small m by capital M. Okay. Here we have the smaller body and the momentum of the smaller body in the numerator, which means directly proportional. Okay. M less than capital M. Therefore, momentum of the first body will be less than momentum of the second body. Okay, there is a direct proportion when kinetic energy is a constant. But in case when the momentum is a constant, when you compare kinetic energy, the lighter body will be having greater kinetic energy. Here the proportion is same. Understood? Example 4. Calculate the kinetic energy of a body of mass 0.1 kg and momentum 20 kg meter per second. Okay. What is the relation between kinetic energy and momentum? We have kinetic energy K equal to P square divided by 2m, where m is the mass and P is the momentum. Here what is given? Mass is given. Mass is equal to 0.1 kg. Momentum P is given, which is 20 kg meter per second. Just substitute the values. K is equal to P square 20 square divided by 2 into mass. Mass is 0.1. Okay. 20 square. 20 into 20 divided by 2 into 0.1, which is 0.2. In order to remove the decimal, I am multiplying numerator and denominator with 10. So, we get 20 into 20 into 10 divided by 2. 0.2 into 10 is 2. Cancelling, here we get 10. 20 into 10, 200 into 10, 2000. So, 2000 joules is the kinetic energy. 2000 joules. Unit of kinetic energy is joules. Clear? Work energy theorem. We know that when a work is done, there is change in kinetic energy. For example, a car is moving. The moving car, when brakes are applied, a force is applied. That is, work is being done. What happens when brakes are applied? There is a retarding force and the body finally comes to rest. That is, the velocity is decreasing and there is a change in kinetic energy. Consider another case. That is, a car is moving, you are applying accelerator. What is happening then? The car gets accelerated. That is, velocity increases. Even here there is change in kinetic energy. So, we understand that to bring a change in kinetic energy, there should be a work done. That is, work done is change in kinetic energy. So, according to work energy theorem, the increase in kinetic energy of a moving body is equal to the work done by a force acting in the direction of the moving body. Okay. So, here consider a body of mass m. Okay, this body is initially moving with the velocity u, initial velocity u. You apply a force. When a force is applied, what happens? The body will start moving with a greater velocity. Okay, it is displaced through a distance s. The velocity becomes v, final velocity v. Okay, so we are going to study a proof for work energy theorem. That is, work is change in kinetic energy or increase in kinetic energy is equal to work done. Let's see. Here, from this, what do we understand? There is a force applied. The body moves from this point to this point. Okay, that is from initial velocity u to a final velocity v. The body is getting accelerated because of a force. Let the acceleration be a. Okay, so we are going to calculate what is the increase in kinetic energy. We know that this is your proof for work energy theorem. We know that work done is equal to force into displacement. Force into displacement. Okay, according to Newton's second law of motion, we have an equation for force. What is it? F is equal to ma. F is equal to ma. So, we are going to substitute it here. Work W is equal to ma into displacement. Displacement is S in this case. Okay, ma into S. Now, here we know that S can be derived from any of the equations of motion. We have studied 3 equations of motions. V is equal to U plus AT. S is equal to ut plus half at square and v square is equal to u square plus 2as. We need a relation between displacement and velocity. That is the third relation. Okay. From this, what is S? We have S is equal to v square minus u square divided by 2a. That is, you are taking this u square to the opposite side, it becomes minus u square 2a into s. So this 2a when taken to the opposite side, it becomes division. Therefore, s is equal to v square minus u square divided by 2a. Substituting here in place of s, work is equal to ma into v square minus u square divided by 2a. Okay, you can cancel this a and this a. We have an acceleration in the numerator and also in the denominator. Cancelling it, what do we get? We get m into v square minus u square divided by 2. Taking this 2 outside, what do we have? Half m into v square minus u square is the work done w. Now, what you are going to do is, you are going to remove this brackets and multiply. Then work will be equal to half mv square minus half mu square. Okay, what is this half mv square and half mu square? Half mv square is the formula to find, or the equation to find kinetic energy. When what is v? V is the final velocity. V is our final velocity. Okay. Then what is half mv square? Half mv square will be the final kinetic energy. Therefore, work is equal to final kinetic energy minus, what is half mu square? U is the initial velocity. Therefore, since u is the initial velocity, half mu square will be the initial kinetic energy. Okay. Kf minus Ki. Kf is final kinetic energy, Ki is initial kinetic energy. Which when you subtract it, what do we get? We get the change in kinetic energy. Therefore, work W is equal to change in kinetic energy. So, this is the required proof. This is the proof for work energy theorem. So, to bring a change in kinetic energy, work should be that either I push it. Okay, that is, I am applying a force. I am an external agent. An external agent, when applying a force on the body, work is being done. It can either be the gravitational force. Gravitational force can do work, right? Or it can be the case with some other external agents. It depends on. So, when a work is done, then there is a change in kinetic energy. It can be increase in kinetic energy or decrease in kinetic energy. In this case, we have taken the increase in kinetic energy. Therefore, increase in kinetic energy is equal to work done. Okay. Increasing in kinetic energy is equal to work done. That is, work changes to energy. Clear? Now we are going to discuss the different forms of kinetic energy. We know that a body can move in different ways. Okay, here there can be translational motion, it can have a rotational motion or a vibrational motion. What is translational motion? For example, a car is moving along a straight road. That is, this is the initial position of the car. It is moving along a straight road to a new position. That is, along a straight line, the body is moving. Then the motion, we call it translational motion. Okay. So, translational motion is the first type of motion. Then, a body can have rotational motion. That is, about an axis, a body is rotating. A fan, the wings of a fan. Then, another example, a spinning top. These are examples of rotational motion. The body is rotating about an axis. A spinning wheel. These are examples of rotational motion. Then you have vibrational motion. What is vibrational motion? If you have a string which is attached on both sides to a rigid support. Okay, to rigid supports it is attached. So what happens? Suddenly when you just plug the string, that is, in case of a violin you can imagine. When you plug the string, what happens? It starts vibrating. It will be having to and fro motions, and finally it will be coming to rest. This type of motion is called vibrational motion. So, a body can have translational motion, rotational motion or vibrational motion. It is not necessary that only any one of this will be there. A body can even have both translation and rotation at the same time. For example, a car which is moving on a road. Consider the case of the wheel. The wheel is both rotating and it is moving forward along a straight line. Then there is both translational motion and rotational motion. Okay, it can have, a body can even have all the three, that is translation, rotation, vibration motion. A diatomic molecule or inside a molecule, or consider a gas. Inside the gas there are many molecules. These molecules will be moving along straight line path. It can rotate, it can vibrate, which means there is All the three, that is translational, rotational and vibrational motion. So depending on this, which type of motion, there are three different types of kinetic energy, three different forms of kinetic energy. If it is translational motion, you will be having translational kinetic energy. Okay, so these are the three types of kinetic energies. First is translational kinetic energy, if the motion is translational motion. Second is rotational kinetic energy, if the motion is rotational motion. And the third is vibrational kinetic energy, if the motion is vibrational motion. Clear? So, we will be discussing these in detail. First, let us discuss translational kinetic energy. So, what is translational motion? I have explained. The motion of a body in a straight line path is called translational motion. Consider all these examples. Apple falling. Apple is falling to the ground in a straight line motion. Yes, from this point to this point, the body is moving along a straight line. There is translational motion. A girl is throwing a ball upwards. What is happening? From this point to this point, the ball is moving along a straight line path. There is translational motion. A boy is pulling a basket. Here again, what is happening? He is applying a force and pulling. That is a body. That is, here the body is the basket. This basket is moving along a straight line path. So, here we have translational motion. Consider the case of a car which is moving along a straight line. In this case, again we have straight line motion or translational motion. Okay, and the kinetic energy of the body due to this motion in a straight line is called translational kinetic energy. So, when all these bodies move, there will be a change in velocity. Initially, for this apple was staying here, there is no kinetic energy. So, when it is falling down, what is happening? Velocity is increasing. Yes, when velocity is increasing, what happens? Kinetic energy, we know kinetic energy is something that depends on velocity. That is, Ke is equal to half mv square, where v is the velocity. That is, kinetic energy depends on the square of velocity. If velocity becomes 2 times, then kinetic energy will become 4 times. We have studied this, right? Because kinetic energy depends on velocity. In which way? Square of velocity. So, when a body is in translational motion, it will be having a change in velocity. Due to this change in velocity, there is kinetic energy, and this kinetic energy due to translational motion is called translational kinetic energy. Consider all these cases. Here, when the ball is moving up, its velocity will be changing. Due to this change in velocity, the body will be getting a kinetic energy. Okay, so understood what is translational kinetic energy? Next is rotational kinetic energy. So, due to rotational motion, we will be having rotational kinetic energy. Consider this example. Here you have a fan. The fan motion is in a circular path, and this motion is an example of rotational motion. Here you have a spinning top. It is spinning about an axis. Okay, with respect to an axis, it is spinning. Okay, here again there is rotational motion. So, the kinetic energy is rotational kinetic energy. If a body rotates about an axis, the motion is called rotational motion, and the kinetic energy of the body due to rotational motion is called rotational kinetic energy, or simply rotational energy. Rotational kinetic energy, or you can simply call it as rotational energy. So, when this body is rotating, what is happening? There is a velocity. So, when this velocity becomes 0, only the body comes to rest. So, when there is a velocity, there is energy, and this energy is the rotational kinetic energy. Okay, understood what is rotational kinetic energy? Clear? So, these are the examples of rotational kinetic energy. The third one is vibrational kinetic energy. Due to vibrational motion, there will be vibrational kinetic energy. So, how? If a body moves to and fro, vibration means it is the to and fro motion about its mean position. This is the mean position. That is, the rest position is called mean position. The motion is called vibrational motion. To and fro motion is called vibrational motion. The kinetic energy of the body due to its vibrational motion is called vibrational kinetic energy, or you can simply call it vibrational energy. As I said, in the case of a string which is with rigid supports on both the sides. So, suddenly when you plug the string, what happens? It will go up, then come down, go up, come down. That is, there is to and fro motion. This to and fro motion is called vibration. In case of a violin or a guitar, what is happening? The strings are vibrating, and the strings vibrating can produce sound. How it can produce sound? Because of the energy. The vibration is because of an energy, right? Here there is a motion. When we apply a force, we do a work, there is motion. This motion will create a velocity. When there is velocity, according to the formula half mv square, there will be velocity. Okay, this velocity will create kinetic energy. Okay, then there is kinetic energy for the body. And this kinetic energy is a work done. Clear? So as we said, a body can have translation, rotation and vibration motion together, which is the case in case of a gas molecule. Okay, a gas molecule taken in a container. It is free to move. That is, free to move means it is having translational motion. It is free to rotate. There is rotational motion. Then it can vibrate. It is having vibrational motion. So a body, that is a gas molecules inside a container has all the three, that is translational, rotational and vibrational motion, and hence it will be having translational kinetic energy, rotational kinetic energy and vibrational kinetic energy. Clear? Next we are going to make a distinction between potential energy and kinetic energy. Differentiate between potential energy and kinetic energy. These are the points. These are the two energy forms. Mechanical energy is of two types, potential energy and kinetic energy. First point about potential energy, the basic point, that is a definition. Potential energy is for a body at rest because of its position, shape or size. Okay, it is the energy possessed by a body due to its changed position or changed size and shape. We had examples. What are the examples? Potential energy, a body which is held at a height, or a body, that is a bow and an arrow, a bow which is being pulled. It will gain some energy. A stretched rubber band, a spring compressed. All these are examples of potential energy. Next, what is kinetic energy? Kinetic energy is just the opposite. Here, if it is rest, here if it is due to motion. Okay, it is energy possessed by a body due to its state of motion. A body that is moving will be having kinetic energy. Okay, when an apple is at the top of a tree, on the tree, it is having potential energy. When it falls, it is moving. There is velocity and it will be having kinetic energy. Okay. Next point, it is equal to the work done in bringing the body to its changed state. That is, when you compress a spring, what is happening? You are changing its shape. It will be having, the energy will be getting stored as potential energy when you compress the spring. Okay. Next, what about kinetic energy? It is equal to the work done that a moving body can do before coming to rest. Clear? That is, moving car, we have taken an example. Applying brakes, finally it comes to rest. So, to come to rest, a work is done. This work is a kinetic energy. Next point, it can change only in the form of kinetic energy. Apple falls. When apple falls, what happens? When apple falls, what happens? The potential energy is getting converted to kinetic energy. When apple falls, there is motion, there is velocity and it changes to kinetic energy. Initially, when it was on the tree, it is potential energy. So, potential energy can be changed only into kinetic energy. But when we discussed about kinetic energy, it is having different forms. What are the forms? Translational kinetic energy, rotational kinetic energy, vibrational kinetic energy can be changed into any forms. Next point, it does not depend on the speed of the body. What is the formula to find potential energy? Potential energy U is equal to mgh. It depends on mass, acceleration due to gravity and height. What about kinetic energy? Kinetic energy formula is K is equal to half mv square. It depends on velocity or it depends on speed. So, potential energy does not depend on speed, whereas kinetic energy, it depends on speed. So, these are the four differences between potential energy and kinetic energy. Next, we are going to discuss about the conversion of potential energy into kinetic energy. Potential energy changes into kinetic energy whenever it is put into use. We will take a simple example. Apple falling. The example we used to take often. Okay. Here, when the apple is on the tree, it is having potential energy. Why? Because the body is at a height. Potential energy is mgh. Okay, when a body is at a height, it is having potential energy. Now, what happens when it falls? When it falls, the body is in motion. When a body is in motion, you know that it will be having velocity. Okay. When there is velocity, what happens? It will be having kinetic energy. half mv square, which is kinetic energy. Okay. Initially, it had potential energy. It changes to kinetic energy. So, at the first point, initial point, the body is having no kinetic energy. It has only potential energy. But when the body falls, what happens? Its potential energy goes on decreasing. That is, height is decreasing. Potential energy will be decreasing. What about kinetic energy? Velocity will be increasing when a body falls down. Yes, when velocity is increasing, what happens to kinetic energy? Kinetic energy depends on square of velocity, which means kinetic energy is also increasing. So, a body that is falling down, potential energy decreases and kinetic energy goes on increasing. At the final point, when the body reaches, that is apple reaches the ground, what happens? There is no potential energy. Potential energy will become equal to 0. Why? Potential energy depends on mass, acceleration due to gravity and height. Mass is a constant, g is a constant, height becomes 0 at the ground. Potential energy becomes 0. What about kinetic energy? Kinetic energy will be maximum at this point. Okay? Kinetic energy is maximum at this point because at the ground the body will be having maximum velocity. Here at this point it will be having some kinetic energy and potential energy. Potential energy will be maximum. So we know that mechanical energy is the sum of potential energy and kinetic energy. Okay, at every point, that is from this point to this point, initial point to final point, mechanical energy will be same. What is happening? The potential energy is getting converted to kinetic energy. Potential energy keeps on decreasing and kinetic energy goes on increasing. Okay, so this is your first example. Understood? Body, when it comes to motion, that is, it is put into use. What happens? Potential energy gets changed into kinetic energy. Okay. Take the next example. Here you can see a nail is penetrating deep into the wood. How is it penetrating? We are using a hammer. Okay. Here you have your nail. Here you have your nail. Okay. This is the wood. Now, when the hammer is just placed over here, does it penetrate? No, right? For that, what is being done? The hammer is lifted to a height. When the body is lifted to a height increases, the body gains potential energy. So, the hammer gains potential energy. Maximum height, maximum potential energy. Now, consider if it is lifted to a very small height, then penetrating will be difficult. So, when the hammer is lifted to a very high height, what happens? It gains maximum potential energy. This potential energy gets converted to kinetic energy when the hammer is in motion. So, while hitting, what is happening? There is motion, there is velocity. Because of motion of the hammer, there will be velocity. Okay. This velocity helps in bringing kinetic energy. We know kinetic energy is half mv square. Hammer is having kinetic energy now. This kinetic energy, what happens? When hits on the nail, what happens? Gets transferred to the nail. Okay, that is the nail gets kinetic energy and this kinetic energy helps in the motion of nail. Okay, motion of nail, that is the nail goes deeper into the wood. This is what happening. Potential energy of the hammer is getting converted into kinetic energy of the hammer and the kinetic energy will get transferred into the nail. We know work done. The work done is now hitting with the hammer. It is a work done. There is change in kinetic energy. This kinetic energy will help the nail to go deeper into the wood. Understood? Next example is the case of a wound up watch. In case of watch, energy is getting stored. Okay. Even you can take the case of toys with which children plays. There, while binding, what is happening? We are storing energy. Okay. We are storing energy. This energy is potential energy. Okay. When it unwinds, what happens? When it unwinds, there is motion. When there is motion, there is velocity. When there is velocity, there is kinetic energy. Okay. So, the spring has elastic potential energy initially. When it unwinds, what happens? The potential energy, elastic potential energy gets converted into kinetic energy of the spring. Okay, the spring will be having kinetic energy. This kinetic energy will get transferred to the needles of the watch and the needle starts moving. Okay, this is what happening. Understood? In case of a watch or in case of toys. In case of toys, while winding, potential energy is getting, elastic potential energy is getting stored in the body. When it is released, the body comes to motion. That is, the spring comes to motion. When there is motion, there is velocity and there is kinetic energy. This kinetic energy gets transferred to the toy and the toy starts moving. Okay, clear? Next example is bow and arrow. In case of a bow and arrow, what is happening? This string is being stretched, same as a rubber band case. In rubber band and paper case, what is happening? I am pulling this rubber band back. Okay, when rubber band is pulled back, there is a change in its state. Change in its state means that is the shape is changing. When it is pulled, in this case, elastic potential energy, the rubber band will gain elastic potential energy. This potential energy is stored in this state. It will be having a tendency to go to its original state. This is a deformed state. Here, the stretched string is having deformed state. So, once released, what happens? It will be coming to its original state. Now, when this paper is released, what happens? It is flying. You can see, right? What is happening here? Once it was released, the body comes to its original state. That is, here the string or the rubber band comes to its original state. It is in motion. Okay? It is in motion. When there is motion, there will be velocity. Okay? Here the string or the rubber band is having velocity. Because of this velocity, it will have kinetic energy. The string is getting kinetic energy. Okay? Here the rubber band is having kinetic energy. The potential energy is getting converted to kinetic energy. Elastic potential energy which was stored is getting converted to kinetic energy. This kinetic energy will get transferred to this arrow. Okay? Kinetic energy of the string gets transferred to the arrow and helps the body move. Okay? The arrow move. Here, the kinetic energy in case of the rubber band's kinetic energy will get transferred into the paper and the paper will fly. Paper will move. Okay? Paper is gaining velocity. It is having kinetic energy and the paper will be moving. Understood? Next example for converting potential energy into kinetic energy, we are taking the case of a spring. So, initially, this is the state of spring. Okay? Normal state. You can either expand it or compress it. This is the compressed state. Okay, when you are pressing, when you are applying a force and pressing, what happens? It comes to the compressed state. When you are releasing or when you are expanding the spring, what happens? Okay, when you are expanding, you are applying, you are pulling, you are applying a force and the body will be expanded. The spring will be expanded. Now, take this case, using a ball, what you are doing is you are compressing the spring. Okay, once compressed, it will have a tendency to come back to its original state. So, this is the original state. These two are the changed states. Okay, here these are the deformed state. One case you are pressing it, you are compressing it. Second case you are expanding it. Okay, now with a ball, when you are pressing it, you are compressing it. Okay, this body, this spring will have a tendency to come to its original state, released state or relaxed state, this state. Okay, once you are compressing, there you will be having the elastic potential energy. Okay, the spring is gaining elastic potential energy. Body is at rest, there is potential energy. Suddenly when you release, what happens? The body will change the elastic potential energy stored in it to kinetic energy. The spring is in motion. When the spring is in motion, it will be having velocity, it will be having kinetic energy. Okay, this kinetic energy of the spring, potential energy of the spring is getting converted to kinetic energy of the spring. Okay, this kinetic energy will get transferred to the ball. Ball will be gaining kinetic energy. Now, ball is in motion, ball is having velocity because of the kinetic energy which it has gained from the spring which was compressed. Compressed spring, when released, the potential energy gets converted to kinetic energy and this kinetic energy gets transferred to the ball and the ball will fly. Okay, ball flies away while the spring is released. Understood? So, these are the examples of converting potential energy into kinetic energy. Potential energy changes into kinetic energy whenever it is put to use. Okay, in the rest state, there is potential energy because of position, size or shape. In the motion state, there is kinetic energy. Okay, that's all for today. In today's class, we have studied about mechanical energy. What mechanical energy is? Two different types of mechanical energy, potential energy and kinetic energy. We have discussed it in detail. Potential energy, two types we have studied, elastic potential energy and gravitational potential energy. Similarly, kinetic energy, the expression for kinetic energy, work energy theorem, forms of kinetic energy, translational, rotational and vibrational kinetic energy we have discussed, after which we have discussed about the conversion of potential energy into kinetic energy. Hope you all enjoyed this session. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai par best hai. Thank you.